Hi, it's time to learn some physics through everyday objects. Have you ever played a seesaw? A seesaw is a long, narrow board supported by a single pivot point, most commonly located at the midpoint between both ends. As one end goes up, the other goes down. Seesaw is most commonly seen in playground, but have you ever thought about the principles behind it? Today, let's dig into this phenomenon together. In essence, a seesaw is a lever. A lever is a simple machine consists of a beam and a pivot point called fulcrum. For a traditional lever, the fulcrum remains in a stationary position, while a force is applied somewhere along the length of the beam. Have you ever wondered what will influence the balance of a seesaw? Actually, there are two factors: the mass of the objects and the distance of the objects from the fulcrum. But how does it work? Let's find it out together. Find a peer in the class and you'll come up with the answer together. Each of you will explore one of the two factors and tell each other how the factor influences the balance of a seesaw. Then, you'll complete a quiz. Remember, you only pass the course if both you and your partner pass the quiz. Anna and Tom are playing seesaw together. Tom is of the same weight as Anna, and he's sitting at the middle point of the left side of the seesaw. Where should Anna sit to make the seesaw move up and down? The correct answer is Anna should sit at the middle point of the right side of the seesaw. This way, Anna is of the same distance to the fulcrum as Tom is, and the seesaw will move up and down. If Anna sits farther to the middle point than Tom does, the seesaw would lean to Anna's side. And if Anna sits closer to the middle point than Tom does, the seesaw would lean to Tom's side. Have you understood? Try another question to test yourself. Now you've understood how the distance of the objects from the fulcrum influences the balance of a seesaw, but how about the other factor, mass of objects? It's time to go to your partner and you're going to teach each other what you've learned. Great work on teaching your peer. I'm sure you must have learned a lot from your peer by teaching what you know and learning what you didn't know. Now, it's time to see whether you've comprehended the knowledge correctly. As we know that there is certain relation between the mass of the object and its distance from the fulcrum, if we represent mass with the letter m and the distance with the letter d, can you choose the correct equation to illustrate the lever principle? The equation is m1 times d1 equals m2 times d2. There is an inverse relationship between mass and distance in the lever law. If we want to keep the beam balanced, we should put the heavier object closer to the fulcrum and the lighter object closer to the end on the opposite side. Lever principle is also applied in many other places such as scissors, tweezers, bottle openers, even our arms. Now, as both of you have learned the formula of the lever principle, you'll complete a final quiz. Remember, you only pass the course if both you and your partner pass this quiz by giving the correct answers. Here, we have a lever with scales on the beam. On each side of the beam, the length is evenly divided into 3 segments. We want to put a watermelon and an apple on the lever. The watermelon is 3 times as heavy as the apple. If we put the apple at the far end on the right side, where should we put the watermelon in order to keep the beam balanced? Let's see what is the result of each option. If we put the watermelon on point A, the lever will tilt towards the left hand. For point B, the lever will also swing to the left. When we pose the watermelon at point C, the beam will stay balanced. This time, we're still dealing with the apple and the watermelon. On each side of the beam, the length is evenly divided into 3 segments and the watermelon is still 3 times as heavy as the apple. Now the watermelon is placed at the far end of the left beam. How many apples we have to put at point A to make the lever stay balanced? Let's see what is the result of each option. If we put 6 apples at point A, the lever will tilt towards the left end. For 9 apples, the lever will stay balanced. When we put 12 apples at point A, the beam will swing to the right. This is what we've learned today. First, a lever is a simple machine consisting of a beam and a fulcrum. And also, if we want to keep a lever balanced, the heavier the object is, the nearer it should be from the fulcrum. The relationship between weight and distance can be described as m1 times d1 equals m2 times d2. So, this is all for today's course. We'll work on your peers' performance to give you overall feedback about this course. You both did a great job. See you next time.